Hello there, you beautiful people, and welcome to this lecture where we're going to be making all the coins. And in the last project, we made a £1 coin, but in this project, we're going to make all of them. That's right, the 1p, 2p, 5p, 10p, 20p, 50p, £1 and £2 coins. They can all rust, they can all be cleaned, they can all be flipped, and they can all be spent. Now that sounds like quite a lot of work, right? Well, it's not actually. Well, not when we use the object-oriented programming principles of class inheritance and polymorphism. And by the end of this lecture, you're going to know what they are, and you're also going to know about abstract classes, parent classes, and child classes, as well as seeing about how to use packing and unpacking that we covered in the last few lectures, how to use those in the real world. So let's go. The first thing we can notice is that all coins work pretty much exactly the same way, right? They all have a diameter, they all have a number of edges, they all have a color, they can all be heads or tails, etc. They can all rust, they can all be cleaned, and they can all be flipped. So instead of making that stuff just specific to the pound class, we're going to make a generic or abstract class called coin, and then every other class gets to inherit abilities from that general abstract class. So let me show you what I mean. So right at the top here, just under the import statement, I'm going to make another class, and I'm going to call it coin, okay? And I'm going to put a constructor in there. I'm going to say define init self, and I'm going to give it two parameters, whether the coin is rare or not, that's going to be default false, and whether it's clean, and that's going to be by default true. So let's set our rare and clean values. Self.isRare equals rare, and self.isClean is going to be equal to clean. Now I have a little bit of an issue. When a pound coin is rare, we've said that its value becomes £1.25, but not all coin values will become £1.25 if they're rare. So what we can do is we can say the value of the coin will become 25% more than what it was originally if it is rare. So let's do that. If self.isRare, then self.value equals self.original value multiplied by multiplied by 1.25, and this is just going to give us 25% extra. So otherwise, if it's not rare, then self.value is going to be self.original value. Okay, but what is this original value? Well, we haven't defined it yet, but you'll see where that comes later on. And we've also got a similar issue for cleanliness. If the coin is clean, we can't just say it becomes gold, because not all coins are gold, right? Some are silver and some are bronze. But what we can say, however, in this general class that's going to work for everything, what we can say is that if the coin is clean, then the coin's color becomes its original color. But if the coin is rusty, then the color is the rusty color. So let's do that. Let's make another if statement. If self.isClean, right, then self.color is going to be self.cleanColor. And we're going to say otherwise, self.color equals self.rusty color, okay, if it's not clean. So there we go. So what are clean color and rusty color? Well, we haven't defined those yet either, but we'll come to them, I promise. So for now, let's just copy over our class methods. So first of all, we have the rust method down here. I'm just going to copy that. But one thing we need to bear in mind is that, by the way, if you're following along, make sure that your methods aren't inside one another. You need to have them outside. Now, we can't really say that when every coin rusts, it's going to go greenish, right? Because not all coins go green when they rust. However, what we can say in this general case is that when a coin rusts, its color is going to become its rusty color for that coin, whatever that might be. So self.color is going to become self.rusty color, whatever that is. We're going to define the rusty colors later. Now, what about the clean method? Well, again, we can't, because this is a general class, we can't say self.color is going to become gold. And the reason we can't say that is because not all coins are golden when they're clean. But what we can do is we can say the color becomes its clean color. So define clean self.color is going to become self.clean color, whatever that clean color might be for that coin. Okay, great. Now what about the destructor? Well, fortunately, that's going to work the same for all coins, so I can just copy and paste that straight over. All coins, when they're spent, are just going to be spent. It doesn't matter what type of coin they are. So that was a nice and easy one. And the same actually goes for the flip method, because every coin, no matter what, it's going to be flipped the same way, right? It can either be heads or tails. So let me just copy and paste that. Okay, we're going to just paste that in there. Define flip, heads options is going to be true or false. You can take a random choice of that, and self.heads is going to become that choice. One thing I am going to add, however, is just another default parameter up here. I'm going to say heads, it's going to be by default, it's going to be true, and self.heads is going to be heads. So they can choose whether that coin is going to be heads or tails or not. Okay, great. Now that we have our general class, what we're going to do is we're going to delete what we have inside the pound class. So I'm just going to delete all of that. Okay, actually, well, delete didn't work. Even Python doesn't want us to get rid of it. Okay, there we go. Now what we're going to do, we're going to make this pound class inherit from the coin class. So we can put coin in parentheses here. Okay, so we're saying we're going to make a class called pound, and it's going to inherit from its parent class called coin. And can you see how just reading that makes sense, right? Class pound coin, right? The pound is what's different, but the fact that it's a coin stays the same. Awesome. Now, when something inherits from another class, so pound is now inheriting from coin, it's going to get the flip method, it's going to get the del method, it's going to get the clean method, it's going to get the rust method, and it's going to kind of get the init method. By default, it kind of just takes all that's in there and pastes it into itself. That's called inheritance, okay, which is totally awesome and saves us a lot of copying and pasting. But we still have some weird stuff lying around, right? What's this rusty color and this clean color and original value business that we've got going on here? Well, those values are specific to each type of coin, right? So what we're going to do is we're going to give our coin, our pound coin, a dictionary of data and store all of this data about the coin, the specific data about a pound. So what I'm going to do is I'm going to make a constructor inside of our pound coin, and in here I'm going to make just a dictionary called data. Okay, just a normal dictionary. And what I'm going to do is I'm going to say, okay, original value is 1.00. Its clean color is going to be gold. Its rusty color is going to be greenish. Its number of edges is going to be 1 because it's a circle. That needs to be a comma. Its diameter is going to be 22.5 millimeters. Need a comma. Its thickness is going to be 3.15 millimeters, and its mass is going to be 9.5 grams. Okay, so we've now got this dictionary of data for the pound class. Now, what we're going to do, well, what we can see here is the original value for the pound coin is £1, right? Its clean color is gold. Its rusty color is greenish. It's got 1 number of edges, and all this stuff. We've got all this data. Now, here's the tricky part. We want to use the parent class, all this, to set up everything else. Okay, everything else for the pound coin, but we've just got this data. So instead of writing self.originalValue is 1 and self.cleanColor is gold and self.rustColor is greenish or whatever in every child class, we just want the parent class to take care of all that. So what we do is we go inside the init function for each small class or each child class, and we run the parents init function and pass it this dictionary. So let me say that again. First, our class's init function is going to run. Okay, we're going to create a pound coin. All this is going to run. It's going to make this data thing. Then inside our init function, we're going to get the parents init function, the parents constructor, to do the rest of the setup, because the only thing that's specific about each coin is its data. And then we're going to call the generic class to set up everything else. Okay, so we're just going to pass all this data into the parents init function and let it deal with the rest. So to run the parents init function, we need to access the parent class. And to do that, we use the super function. So super, like that. Now a super class and a parent class are the same thing. So super just means the parent class. And in this class, we want to run the init function or the constructor and pass all our data as keyword arguments. So original value equals 1, clean color equals gold, rusty color equals greenish. Okay, and how do we do that? Well, what we do is we unpack the data, okay, from this dictionary into keyword arguments. And if you remember about packing and unpacking that we did in the function section of the course, this is where we'd use it. So what this is going to do is it's going to run the coin class constructor and pass it original value equals 1, clean color equals gold, rusty color equals greenish, num edges equals 1, diameter equals 22.5, thickness equals 3.15, and mass equals 9.5, okay? All as keyword arguments. Now, what we need to do is let the parent class be able to accept all that data. So we're going to go up the top here, and we're going to pack down all that information into keyword arguments called kwargs. Okay, and I think that's the right place to put it. I'm pretty sure. So let's just leave that there, put the kwargs right at the end. And what this is going to do is it's going to take those keyword arguments and pack them down into a dictionary called kwargs. So what we've done is we've got a dictionary of data here, and we packed it down and put it in the function as keyword arguments. We unpacked it, sorry, and put it as keyword arguments, and then we packed it down back into another dictionary called kwargs. Now, as with any constructor, we need to do all this self.original value equals blah, self.rusty color equals blah, self.diameter equals blah, clean color is blah, whatever. Now, the way that we do that is we loop over those kwargs, those keyword arguments. We're going to say for key, comma, value in kwargs.items. Keys is going to store the keys in the dictionary, and value is going to store the values. And we're going to use the set atta, short for set attribute or set state, basically. What we're going to say is self, key, and value. So let's say if we sent into it original value 1, this is going to make the code self.original value equals 1. And this is a really beautiful piece of code, because we could send in as many as we wanted. This data could be as complicated as we wanted, and it's going to set up all of the states for us just like that. So what this is going to do is it's going to loop through all of the items. Let's say the first item has the key original value and the value of 1. The key is going to become original value, the value is going to become 1, and set attribute is going to basically write self.original value equals 1. Okay, that's what it's going to do. If it said thickness, it's going to say self.thickness equals what is it going to say, 3.15. Okay, but the thing is, it's done it in a flexible way that we don't need to worry about passing in or typing it out ourselves. And this is going to work in general for any dictionary that you pass in. So we've now taken care of all the variables here that we haven't defined yet, like clean color and rusty color, and our classes should work. So that's pretty much it. So let's see this work for a pound coin. So let's run this. We're just going to run this code, And that's worked fine. Now let's make a £1 coin and make that a pound. Now you can see that that's worked, right? So let's have a look at the color. Let's just see the £1 coin dot color. And it's going to say it's gold. Magic. Okay, let's rust it. £1 coin dot rust. And now look at the color. Now it's greenish. Amazing, right? So even though we defined the rust function all the way up here, this is the only place that we see the rust function. And it's very general. Your color is going to become your rusty color. If we go in the pound coin, there's no such thing inside the pound coin as rust, but it inherited the method, and we gave the rusty color and the clean color to the constructor, which then did all the setting up that was required for us. So how cool is that, right? So for a new coin, we only need this much code. And that's exactly what we're going to do in the next video. We're going to set up all of the other coins using exactly this thing here. And well, then by the end of it, we should have our own set of coins, all with their own different variables and their own different bits of data. So for that, I'll see you in the next video.